Hi everyone, this is 5.3, so we learn how to use synthetic division to divide a polynomial by a binomial. If we recall from about grade 5 how to use long division, then we will be able to use that same process as we use long division with polynomials, and then the shorter version, which is synthetic division. So 7 goes into 60 8 times. 7 times 8 is 56. Subtract and bring down the 1. 7 goes into 40 5 times. 7 times 5 is 35. Subtract and we get 6. So we'll have a remainder of 6. Sometimes they ask for that to be written in a division statement, and in a division statement we will write 601, which is our dividend, equals 7, our divisor, times by the quotient, 85, plus our remainder of 6. So quickly looking at their page here, the dividend is the number or the polynomial that we are dividing to begin with. Quotient is this part. Divisor is what we are dividing by, and then the remainder is anything left over at the end. Let's look at the question that they've done here in using a polynomial. So they've got 3x squared. Well, let's start here. 3x squared minus 7x minus 9, and we're going to divide that by x minus 2. So using long division, we would write it out in descending order, and notice they have a 0x squared in there as a placeholder. Then x minus 2 here. This is weird, and you don't really need to know, but here's what happens. You take whatever the coefficient is in front, divided by the x part, and so 3x cubed divided by x is 3x squared. That will go directly above the x squared. Then, like here, 3x squared times x minus 2 is 3x cubed minus 6x squared. We'll subtract, so 0 minus minus 6 will be positive 6x squared. Bring down the negative 7 and start again. So 6x squared divided by x will be 6x. 6x times x minus 2 is the 6x squared minus 12. When we subtract, we're subtracting, so add the opposite, and we'll get 5x. Bring down the 9, negative 9. And start again. So 5x divided by x is plus 5. 5 times x is 5x minus 10. Subtract, so adding the opposite, and we end up with a remainder of 1. So in synthetic division, what they've done is shorten that process. So here we see below, they've written this exact same thing, except for they have left off the variable. Same here. Here's one difference. They do it using addition. I'm going to do it using subtraction. So add that negative back in, and that is not what would make it subtraction. The negative is because that is what we're dividing by, x minus 2. So I'm going to keep that negative. And then we're going to use the same exact process we did here. So we'll bring the 3 down to start with. That's always your rule with synthetic division. Down it comes. And now, negative 2 times 3 will be negative 6. We'll subtract, so 0 minus a minus 6 will be plus 6. Multiply those together, negative 12. We'll subtract, so add the opposite, and we get positive 5. Negative 2 times negative or positive 5 is negative 10. We'll subtract negative 9 plus 10 is going to give us a positive 1, which is our remainder. So then if we write the division statement, you can see they've written their dividend first, then the divisor times the quotient, and the remainder at the end. Often, to make things shorter for you, they will name this guy, like they'll call it P at X. So then here, when you do the division statement, you'll get P at X equals this. Then you don't have to write out the original equation every time. On the next page, I'm going to use their space but change the example. So you'll see in this example, we don't have the terms in descending order. We'll place them in descending order. So negative x to the 4 plus 3x cubed plus 0x squared as a placeholder. We need a squared part. Plus 3x minus 20. Then we're thinking that one is the arrangement we need for dividing by the x plus 2. Now let's set it up with synthetic division. So we'll just use the coefficients. So negative 1 plus 3 plus 0 plus 3 minus 20. All of that we're going to divide by x plus 2, so plus 2 out front. And here we go. So the negative 1 drops down. 2 times negative 1 is negative 2. Subtract means I'm going to add the opposite. So 5. 2 times 5 is 10. Subtract gives me negative 10. 2 times negative 10 is negative 20. Subtract, add the opposite, so I'll have 23. 2 times 23 is 46. Subtract, and I get negative 66. So here I have my quotient and there's the quotient and the remainder. So my answer then is negative x to the, and it will always be 1 less than the degree you started with. So negative x to the 3 plus 5x squared minus 10x plus 23 and remainder of negative 66. Hooray! If they wanted you to write the division statement, then you would write P at X. Well, you would hope that they called it P at X because we don't want to write it out all again. So I'm going to call it P at X equals our divisor, x plus 2, times the quotient, negative x cubed, I guess here's easier, plus 5x squared, minus 10x, plus 23, that doesn't fit, and then our remainder, take away 66 at the end. Let's do example 3 at the bottom of the page. So if x plus 3 is the divisor in the following synthetic division, calculate the values of m and p. So we're going to divide by the 3 plus 3. You can put the plus or not, it doesn't matter. They've already dropped this down for us. 3 times 2 is 6. We're going to subtract, so 2 take away 6 is negative 4. 3 times negative 4 is negative 12. We're going to subtract, so add the opposite. And right here, we can make a little equation for ourselves. Negative m plus 12 equals 2m. And I can solve, so plus m, 12 equals 3m. Divide by 3, and I get m equals 4. Well, I know this section is 2m, so that would be 4 times 2 would be 8 for here, so I'm just going to use that as I work through the next part. 3 times 3 times 8 is 24, so n must be 24. And then I'm subtracting, so 16 take away 24 is negative 8, which must be p. Nice, eh? Okay, example 4 on the top of 305. When this nice polynomial is divided by x plus 2, the remainder is 3. Find the value of a. So let's write what we know. 2 take away 4 plus a plus 3, and I'm checking as I go that I have x cubed squared to the 1 to the 0 for my x, and then divide by the 2. By the way, coming up, this part is going to be a factor with some certain conditions, but you're thinking of that as a factor in the future, just so you don't get that confused with some more exciting things we're going to do. Okay, and remainder of 3, we'll use that in a second. So down we come, and 2 times 2 is 4, subtract is negative 8, 2 times negative 8 is negative 16, subtract, add the opposite, so this will be a plus 16 in that space. 2 times a plus 16 is 2a minus plus 32. And we're going to subtract that whole thing. Here's where we're going to put in the remainder. We know that remainder is 3. So we can make a little equation for ourselves. 3 take away the 2a plus 32 has to equal 3. And now we can solve. So take away 3 is going to be negative, and I'm going to multiply the negative 1 into both terms. So negative 2a minus 32 equals 0, plus 32, negative 2a equals 32, divide by negative 2, and a equals negative 16. We're going to skip the next part. This is only in university that we use the synthetic division with a divisor out front that has a coefficient greater than 1. So in the bottom, number 5, we're going to use this space to not this little question at all. Okay, instead I'm going to do 2x squared plus 11x minus 6, all of that divided by x plus 6. We could just factor this like we have in the past. So 2x and x. What if I do 1 and 6 and minus and plus? Plus 12, take away 1, yes, is our positive 11x. So this will factor and give us 2x minus 1 and x plus 6. Meaning these both are factors of our original 2x squared plus 11x minus 6. Using synthetic division, here's what we're going to find. 2 plus 11 minus 6, all of that divided by plus 6. Down comes the 2. 6 times 2 is 12. Subtract gives me negative 1. Negative 6, or 6 times negative 1 is negative 6. Subtract gives me 0. This is a super great thing when our remainder is equal to 0. Hooray! This means that the x plus 6 here is a factor. Which we'll use in our next lesson. And this quotient that we came up with is a factor as well. So 2x minus 1 is a factor. Hooray! And if we look, oh, yes, we already knew that. We'll do this with longer equations. Okay, hope that helps.